All engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to the Naked Scientists podcast. This is the programme that brings you the biggest breakthroughs and talks to the major movers and shakers in the worlds of science, technology and medicine. I'm Chris Smith, and this week we're asking, what is a white Christmas and are we going to get one? This week, in partnership with UK Research and Innovation, we're asking whether it's going to snow on the 25th of December. Now, this is frequently called a white Christmas, and at this time of year, weather forecasters as well as the bookies are busy looking at the odds. Before we get into how a white Christmas is officially defined, though, we first need to explore how weather forecasts even get produced. And our guide for this bit is Aisling Creevy, a meteorologist and an ITV weather presenter. Aisling also co-hosts a podcast called For the Love of Weather.
One of my favourite weather instruments is a barometer, and a barometer tells me about pressure change, and pressure change is about how heavy the atmosphere is and how much of it is moving around. So as that's changing, I can tell what the weather is going to be about whether that barometer is going up. So if the atmosphere is getting heavier, then I know the weather is going to be less changeable. And if the atmosphere is going to be lighter or low pressure, then the weather is likely to be more changeable. So there's lots of different ways to put together a weather forecast. So it can be quite complicated looking across the globe, or it could just be you on your own looking out at the sky and understanding, oh, okay, the clouds are coming from this direction today and they're up really high now. And then if you notice through the day that they start to lower down, well, then you know that a change is coming and it's likely to rain. So there's lots of ways to make a weather forecast.
So when you talk about a low pressure, what actually is that?
Low pressure is an area of weather that's changing quite quickly. You see it on a map, it's a circular feature, and you could have something called a cold front or a warm front. And this is where we have that really sharp temperature change, and that's normally wrapped into this low pressure. That's what's created in the first place. And it means that some bad weather is on the way. So if it's a cold front wrapped into this area of low pressure, then we know colder air is going to follow on through once that cold front has cleared through. So once that area of rain has cleared through. If it's a warm front, then we know warm air is going to follow on through. But low pressure is essentially a huge area where air is very quickly moving away from that area. And that's what's creating all of this unsettled weather.
And why does that bring bad weather? Why would air moving away change the weather in that way?
What you have essentially is these two air masses mixing. So any one weather front is normally made up of two air masses that meet together. And when you have low pressure, if it's moving away quite quickly, that means that the air that's in that area is changing quite quickly. And when you have that very quick change, it means you've got a very quick change in pressure. And if you've got a quick change in pressure, you've got a quick change in temperature. And those two things together, that recipe together, brings us what we perceive as a weather front. But we really only experience the weather in any one spot. As a weather forecaster, you're looking at these much larger areas of what's coming downstream and watching how is that coming towards you.
So if I want a white Christmas or I want some snow, what do I need to look for?
What you would need for snow is some cold air, but it's no use having that cold air if you don't have some sort of moisture in the air to actually make that snow. And you need some other feed of that. So you need that supply to be constantly replenished to actually make snow. So the essential ingredients for snow is cold air and some moisture as well.
And therefore, what would the weather pattern look like? So if we're trying to predict it will snow this month, what sort of things do we need to see coming across the Atlantic? Because the prevailing wind systems come from the Atlantic towards us, don't they? So I'm going to be looking across the Atlantic. What am I looking for to say, aha, that looks like the right recipe for a white Christmas?
What we're looking for is cold air somewhere from the north. So that would be a northerly, a northeasterly, sometimes a northwesterly as well. And the seas are much colder up there as well. So my spidey senses start going off when I see a northerly breeze developing, and not just developing for, let's say, 12 hours. When I start seeing a northerly breeze over the space of a few days. And that means that that air has time to travel all the way from where it's come from. Normally, in this case, I'm going to use the Arctic as an example, and it comes over a very cold ocean as well. That's what I'm looking for snow. So it's some sort of northerly component. We need to have the moisture, so somewhere over coming down from the North Sea somewhere, and it needs to be there for enough time for the whole atmosphere to get cold so that when it does rain or showers do develop, then we can see snow actually falling to the surface. So we need the air temperature to come down as well, and we need it to be somewhere around 3 degrees or below. So I wouldn't be looking to the west, I would be looking to the north.
So when you say, this is what I think the weather's going to do for the next week, are you usually pretty much spot on these days?
We are much better at forecasting. And even earlier on in December, for example, I was looking at some what we call longer term output. So you're not looking for the weather on any one day, you're looking for trends. So is it getting warmer? Is it getting colder? And from very early on in December, I could see that most of December was quite mild. So that is a capability that certainly didn't even exist 10 years ago, perhaps not even 5 years ago, but the accuracy of that is much higher now.
Is that pattern set to play out for the rest of this month then? We're going to have a warmish December.
So at the time of recording, I can say I think that Christmas Day is going to be very mild, and sometime around New Year, the weather will settle down and get a little bit cold.
So, will she be right? Warm for Christmas, cooler across New Year, and what will our other experts forecast? Aisling Creevy there, meteorologist, weather presenter and podcaster. Now, Aisling gave us an overview of the recipe for a white Christmas, but what exactly do we need for it to happen? There's perhaps no better person to ask than the former Met Office and also BBC weather forecaster, Peter Gibbs. He also spent 2 years living and working in Antarctica in the early 1980s, and he saw nothing but snow and ice during that time, so he's the perfect person to tell us. I began by asking Peter to define a white Christmas for us.
Well, surprisingly, it doesn't mean snow on the ground. It's actually down to the bookies' definition of a white Christmas, which is if you put a bet on a place for a white Christmas and one flake of snow falls out of the sky in that spot, that counts as a white Christmas. So it's a fairly low bar. We've had 54 official white Christmases in the last 65 years. Only 4 times, though, with snow actually lying on the ground on Christmas Day.
When are we most likely to see snow lying on the ground in a latitude like the UK?
Well, as climate change, of course, it's happening less and less, but it tends to be during the second part of the winter. Surrounding seas are still fairly warm during the autumn, early part of the winter, so that reduces the chance. So it's more of a sort of January, February thing, typically, when you get a cold outbreak of air, particularly from the north or the northeast.
And what are the ingredients then of getting a snowfall? How does the process work?
It needs to be cold, obviously, and you need moisture. So that basically means you need some cold clouds. But surprisingly, maybe, not clouds of ice crystals. Initially, those clouds will probably be composed of supercooled water droplets. You can actually cool water down to way, way below freezing before it'll actually freeze spontaneously. Now, the process is helped if you have what are called condensation nuclei, little bits of dust floating around in the atmosphere, pollen grains, those rough surfaces that the water droplet can form around can then provide the right sort of structure just to kick the water molecules into the right orientation with the temperature low enough to start forming ice. And then once you've got that initial ice crystal, it then grows by deposition from water vapor around all the ice crystals, and you start to get that familiar snowflake that you see on the Christmas cards, things like that, those beautiful crystals, which once they're big enough, will actually start to fall towards the ground. And depending on the temperature conditions they encounter on the way down, will either reach the ground or not.
Given the prevailing wind direction where we are, that's coming from the west, does this mean then that most of these snowstorms are born out on the Atlantic, which separates us here from America? So they're going to sort of be born as water evaporating up from the ocean out west, and it's when they get here, they may have turned into snow in the meantime.
That would tend to be the original source for the moisture. It's a bit of a battleground in the UK, though. We get so many different weather influences. You know, wind from the north, it's from the Arctic. Wind from the east in the winter, you're coming in from Siberia. So that's a cold source. Bump that up against the warmer, moist air coming in from the Atlantic. That's a fantastic recipe for producing snow. And actually, every single raindrop that falls started life as a snowflake. So the process is the same. It's just what happens in that bottom few thousand feet of the atmosphere that determines what we actually see here on the ground.
So it's all ice in the clouds, but it's air it rains down through that either melts it or allows it to stay frozen during its journey to the ground.
Exactly that, yes. The process to grow snowflakes, which then melt into raindrops if it's warm enough down near the surface, is always the same sort of process. It's the most efficient process to get things going. In the UK, we tend to have surface temperatures in the winter in a snowfall situation somewhere between sort of 0 and 3 or 4 degrees. That means the snow can just about make it to the ground. It also means that the flakes just start to melt as they get closer to hitting the surface. That means those little individual flakes melt slightly, they can then stick together and refreeze, and that's when you get those big sort of dinner flake snowflakes coming down that really start to pile up quite rapidly. If it's really cold all the way down, then the flakes don't freeze together because they don't melt, and that's when you get that dry, powdery snow, which of course skiers love, but maybe rail operators don't.
When it melts, it turns into water. That's transparent and certainly isn't white. When it's on the ground, it is white. So when does one turn into the other?
But of course, ice isn't white either, is it? Ice is transparent. It's just the fact that there's lots of these complex shapes all piled up higgledy-piggledy, one on top of the other. So the light hits them, bounces around all over the place, gets scattered in all directions, and comes back at us just as a sort of opaque white layer. So it appears white, but really it is transparent.
And what about the other myth then of you never find two snowflakes the same shape or size? Is that true? Or is that actually also a myth-conception?
Well, I don't think anybody's actually gone out and examined every single snowflake that's ever fallen to prove or disprove that myth. But it certainly seems to be the case. There are so many different variables in terms of just how much vapor there is around the developing crystal, for example, that kind of determines how the shape grows, how it develops, what direction the little fingers grow in as that snowflake gets bigger and bigger. So if you had the time to look, you might well find two that are very similar, but in general, every snowflake is different, yes.
And what about the claim that it's too cold to snow? You often hear sort of sage, aged country dwellers looking at the sky and then sort of rubbing their chin and saying that. Is that true?
Yeah, absolutely. It's like a lot of these weather law things, Chris. There's usually a grain of truth in there somewhere, and it's the same with this one. The coldest weather we get in the UK is usually when we've got high pressure in charge, so very, very settled weather with clear skies largely overnight, which in the winter means that you've got more energy going out to space during the night than you've got coming in during the day. So it gets, if nothing else changes, colder and colder and colder. But then, that means that we're not going to get any weather fronts coming in. So you can't have anything that's producing snow. Also, the colder it is, the less moisture a particular air mass can hold. So that again reduces the chance of snow too. So it kind of has some truth in there, but it's more a sort of symptom than a cause, if you like.
And your forecast for this Christmas, Peter? Not going to put you on the spot or anything.
Oh, God, I used to dread this time of year when I was presenting the weather on the TV. Because, it'd be 2 or 3 weeks out and the presenters start saying, is it going to be a white Christmas, Peter? Or if you had a couple of days of cold weather, then it'd be, is it going to be a white Christmas? And it's impossible to say for 2 reasons. First of all, it's hard to do anything detailed in the weather forecast more than about 4 or 5 days ahead, despite the fact weather forecasts are better than they ever have been these days. But also because snow is so marginal in the UK. Just a temperature difference of 1 or 2 degrees at the surface means the difference between snow and rain, or just 100 meters difference in altitude can make the difference between snow and rain. So you're not going to pin me down yet, Chris. Ask me the day before Christmas.
Keeping his Christmas cards close to his chest. That's Peter Gibbs, formerly from the Met Office and the BBC.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, Perfect music for audio and video productions.
This is the Naked Scientist podcast with me, Chris Smith, and today, in partnership with UK Research and Innovation, we're exploring the concept of a white Christmas and whether we're going to have one for Christmas Day on the 25th of December. Now, we're going to hear from Len Shaffrey, who's a researcher at the National Oceanography Centre, and he's also the former site lead at the National Centre of Atmospheric Science. He's very interested in the role that our oceans play in the weather, and he's also at the cutting edge of how we make forecasts.
The oceans play a really key role in climate. They move heat from the tropics all the way up to the poles. And so they have a huge influence on the atmosphere above them. So in particular, in the North Atlantic, we have what's called the Atlantic Meridional Overturning Circulation. So that's a big conveyor of warm water that moves heat from the tropics in the southern kind of North Atlantic all the way up into the Arctic. And so that has a huge influence on the kind of climate that we have in Europe and in the UK. You know, if you went just west and crossed to kind of like Canada, where it's absolutely freezing, and you come back across the east, across the North Atlantic to the UK, you'll find it's a lot warmer. And that's partly to due to the fact that we have the overturning circulation that's bringing all that warm water and energy up into northern latitudes.
We're not far adrift on how far north Moscow is, are we? And you think what the difference is in temperature, that's the point you're making, isn't it? That we have all this warm water around us and Moscow doesn't, so we stay much warmer than we otherwise should do. But if that turned off that circulation, does that mean then that through climate change, which could turn that circulation off, we end up with colder winters and more white Christmases?
It's one of the questions that we're trying to address around climate change and understanding what the sensitivities are in terms of the ocean circulation. So, we've kind of got two effects here. One is that under climate change, we expect temperatures to get warmer as we pump more CO2 into the atmosphere. That will change how our temperatures respond, and so we'll have a warmer climate. At the same time, we might get kind of the ocean basin scale. So if there's a slowdown in the overturning circulation, that will mean less energy going up into northern latitudes, and that will mean a cooling. So it'll be a balance between the two. So how much temperatures are rising due to climate change and how much they might kill due to changes in ocean circulation. So that's one of the real big uncertainties that we're trying to think about in terms of what we're doing in ocean science.
Presumably technology is proving really crucial here in the sense that it enables us to run simulations in the same way that we're modelling weather to work out whether it's going to rain tomorrow. You must be doing similar things for the oceans to work out how they're going to change in the short and long term, and therefore the effects that's likely to have on nearby weather and a white Christmas.
In fact, we use the same models to model the ocean as we do in the atmosphere. So in the atmosphere, we have kind of atmospheric models where we try and model the flow of the atmosphere. We include lots of processes, such as kind of like how the surface is affecting that, the mountain ranges, how clouds are changing, how things like the jet stream are moving. And we do a very similar thing in the ocean. So we have, again, trying to represent all the physics of the ocean. So we're trying to represent the ocean currents. We're trying to represent the ocean temperatures. As you go down depth into the cold abyssal ocean, we're looking and modelling the ocean salinity, so you can see how that's changing with time. And of course, then we're including things like sort of ice processes as well. So up in the Arctic and down in the Antarctica, how the sea ice is affecting the oceans.
I suppose that AI must be also on your radar in the sense that it seems to have made inroads into every element and aspect of science, but it's very good for spotting patterns in data. And therefore, it must be in your arsenal now.
AI has kind of revolutionized, weather forecasting. So we've gone from using these physically based models where we're trying to model all the processes that we can see in the climate system and capture them and put them, kind of encode them in equations and put them into our climate models and our weather forecasting models. AI takes a different approach. So you kind of, it's data driven. So you have lots of observations of both the atmosphere and the oceans, and you're using AI to pick out those weather patterns and using that to make forecasts. So that's completely changed how weather forecasting is done. So there's very skillful weather forecasts that can now be done with artificial intelligence models, and we're looking at those applications for the oceans as well. So can we move from that physically based kind of modeling that we do at the moment to a more AI data-driven approach? So take the ocean observations and use them to model the oceans.
Do we know why these AI-based approaches are better, though? Because they clearly are superior. Everyone says they're getting much better performances of their predictions when they use these systems, but they can't really say why because the AI doesn't tell them. Why are these systems potentially more powerful than trying to model the entire atmosphere of a planet in a computer and use physics to solve the problem?
So, I mean, the original way that people made weather forecasts was using kind of previous weather forecasts to try and predict, or weather patterns to try and predict what might come a few days ahead. And people have been using those kind of approaches even up to recently. I think the reason why AI might be so good is just simply it's able to pick out the patterns that a human brain can't do, and can really pull out the information that other people can't see. And I think that's really where AI kind of excels. And it has been a surprise to many people that they're able to push the skill in weather forecasts so far forward.
Indeed, and the quality and accuracy of weather forecasting really is second to none these days. It's definitely a far cry from when we used to watch the weather forecast to stick magnetic suns and clouds on maps on the telly back in the day. Do you remember those days? Anyway, that was Len Shaffery. He is at the National Oceanography Centre. Now, finally this week, we're going to hear from Aidan McGivern, who's a senior weather presenter at the Met Office. We're recording this item 10 days before Christmas Day, so things, as we will hear from Aidan in the piece, could definitely still change. But I began by asking him how his employer actually defines a white Christmas.
The official definition from the Met Office simply requires that a single snowflake be observed at one of the official Met Office observing stations at any point during the 24 hours of Christmas Day. So we don't need a blanket of snow covering the country. We don't need those picture postcard scenes. We just need a single flake of snow. And that happens a lot more often than you might expect.
Is someone actually eyeballing this? Because that sounds a pretty loose definition, one flake of snow. I mean, how big is that? That must be impossible to say with any certainty that's really happened.
There are a couple of things that go into determining this. Some of our weather stations are manned, so a person watching out the window and seeing whether a snowflake falls from the sky. A lot of our weather stations these days are automated, so we have these automatic instruments that can detect the kind of precipitation that is falling from the sky. But that information then is verified by the chief meteorologist the next day. So they will look back at any stations that have recorded a snowflake, and they will test it and see if that is a realistic observation based on the conditions from the day.
That's a pretty big responsibility resting on the shoulders of that person who goes out and has a look, though, isn't it? They're making the official call, and the bookies are going to either love them or loathe them.
It is, of course, yeah, because a lot of people have a lot at stake when it comes to a white Christmas. And the bookies will have bets on different locations in the UK or the UK as a whole. There's a lot of responsibility that is taken very seriously by the Met Office.
Given that you've made me realise it probably is more often that this happens than we think, when was the last time we actually had an official white Christmas?
So 25th of December, 2023, 11% of our observing network recorded falling snow. No observations of lying snow on that day. And before that, 2022, 2021, 2020, all also qualified in that technical, very loose definition that we have. Sleety shower in Shetland would have made it a white Christmas, but it won't have been a widespread picture postcard scene that people are often longing for at this time of year.
It doesn't have quite the same jingle bell ring to it, does it? But how far back do your records go? The reason for asking the question, I'm interested in whether the pattern is changing. Are white Christmases and those very traditional Christmas scenes becoming less common?
I'll take the public perception of a white Christmas definition and talk about what we've seen since 1960. And the Met Office did a study on this in which they looked at how many Christmases 40% of our observing network have had lying snow on Christmas Day. So that's the kind of widespread snow blanket that people might have in mind when they think of a white Christmas. How many times do you think since 1960 that's happened?
15, 20?
It's only happened 4 times
Really?
since 1960.
It's probably that we have this nostalgic view of it, and it's less common than we actually think, isn't it?
Exactly. So 1981, 1995, 2009, 2010. Those are the 4 times that we've had lying snow recorded at 40% of our observing network. But you go back to Dickens' time, for example, when Dickens grew up, this happened every few years.
How far out do you really have an inkling? On those years, that 1981, I remember that one especially because that was the year my brother was born and my mum couldn't get to the hospital to have him initially. But how far in advance do you think you can get an insight into whether this is likely to happen or not?
Well, we're currently 10 days ahead at the time of recording. I remember working on Shift in 2009 and 2010, so the two most recent widespread white Christmases. And you had a very strong inkling at this point that you were in the midst of a very cold month and there was already snow on the ground at this point in 2009, 2010. So you had this idea that would continue up to Christmas. But our forecasting has advanced further since then, and we can get a reasonable inkling as to which way the weather is trending 14 days ahead, so 2 weeks before Christmas Day. And we were looking at this at the end of last week, and there are now some clear trends starting to emerge for Christmas next week.
Aisling, who we spoke to earlier in the programme, was pretty lukewarm on a white Christmas. I mean, she said that the indicators are that it's looking like it's going to be quite balmy. Do you agree? Is that still the case?
It's changed a little since you spoke to Aisling, and it's changed in a slightly different direction now. And there are emerging signals coming through from the computer modelling. Now, when we're talking about a forecast that's more than a week ahead, we don't just look at one computer model simulation, we look at dozens. And that's because of chaos theory, the idea that a subtle change at the start of a forecast can escalate into a much bigger difference later on. So we make these subtle changes with numerous different simulations of the atmosphere at the start, and then we see how much they might change in the future. And it's by analysing what all these dozens of computer model simulations are saying for next week that we get an idea, a probabilistic idea of the most likely weather patterns for the Christmas period. And a trend that's emerging now, and whilst we can't give specifics, more than 3 to 5 days ahead, we can talk about whether it's turning colder or drier or wetter or windier, etc. And what we're now seeing emerge in the computer modelling is that higher pressure is becoming more likely for the Christmas period. What does that mean? It means that the low pressure that we've been bombarded with during December so far, that has brought us so much rain and mild air from the Atlantic, is becoming less likely through the Christmas period, with drier and perhaps colder weather becoming more likely. So what I can say at this point is that there's perhaps a welcome trend for many of us towards drier and a little colder, but mostly drier weather for Christmas Day. It's too early to give specifics on whether it will snow at a particular postcode at a particular time on Christmas Day, but it does look likely that it'll be less wet and less mild compared with the first half of December. And I suspect for many people, a crisp, dry, perhaps frosty Christmas is welcome news, even if it's not going to be widespread picture postcard scenes.
So there you go. Not going to snow, but not going to rain either. So that's a major Christmas present. Aidan McGivern there from the Met Office. Well, that's it for this week and pretty much also for this year. Indeed, where did 2025 go? Next time, to round off 2025, we're going to be taking a look at some of the year's major scientific highlights. Do please join us. In parting, a huge thank you to all of you who help us with our running costs. This does make a massive difference and we really appreciate hearing from you. We read all of your messages and I do try to reply to every single one of them. If you would like to join the people who help to keep the show on the road, please do head over to nakedscientist.com/donate and put something in our Christmas stocking for us. You can also leave us a review on your favourite podcasting platforms, as well as following us on Instagram, LinkedIn and X. That's wonderful too. The Naked Scientists is supported by Rolls-Royce. I'm Chris Smith, and from all of us here at the team, thanks for listening, Merry Christmas, and until next time, goodbye.